Well, here I'm going to talk about I'm going to provide an overview of some of the key use cases and some of the approaches you can use to implement SNOMED CT, because I know, and I'm also going to speak of some bit about some interoperability challenges. So Liara have provided a good overview of all the features in SNOMED CT, so it can seem quite overwhelming. How do we start this? Because as you hear, SNOMED CT can do a lot of things. There's so many things that you can achieve with SNOMED CT, but how to digest all that and find out where to start can be challenging. So as Liara said, SNOMED is a multilingual clinical terminology. It's global, and it's intended to support the consistent recording of data in clinical records. But how do you get there? I can see there's some background noise there. Okay, good. So how do you then go and implement it? And I'm sorry to disappoint you, because there's not a single correct solution to how to implement, because SNOMED CT is also designed to be customizable and to be tailored to the needs of our users. So it actually depends on what you need and what you want to do with SNOMED. What are the benefits you want to achieve? And that can vary from country to country. So SNOMED CT is designed to suit a range of business needs. So one of the things that you have to consider is, what is it that we want to do with SNOMED? So here in this presentation, I want to give you an overview of some of the various things you can do with SNOMED. And then the next step is then to consider, okay, which parts of these implementation approaches do we then want to take? Because SNOMED CT can function as a common language. It can function as a code system. It can function as an indexing system, as an interface terminology, a dictionary, and an extensible foundation. So these are the 6 categories. If we try to categorize the approaches to SNOMED CT implementation, we can categorize it into these 6. And I want to give you some insights to what we mean by these different approaches. So using SNOMED CT as a common language is what you would take if you want to communicate clinical data in a meaningful way, or if you want to integrate heterogeneous data. So one benefit that you can achieve with SNOMED is that you can ensure that organizations around the country, around the world, can actually communicate and understand the clinical information being shared. But it's also to make the clinical data set more homogeneous, which is useful because it can simplify the processes you use for data retrieval and analytics. So let's look at an example. You can imagine a situation where you have multiple hospitals or multiple organizations recording the same information in different ways. So here we have a set of organizations using different codes for the same clinical meaning and different terms for the same clinical meaning. In this case, it's an intervertebral disc prolapse. So organizations or hospitals or systems, they would use this different terms and different codes to represent the same clinical idea. And that challenges communication, because if we were to, for example, move a patient from one hospital to another, and then also forward the record of data, this system over here wouldn't know what BA00 means. So they wouldn't be able to understand. Of course, a clinician, if they saw even though they use intervertebral disc extrusion over here, and they saw slip disc, the clinicians would apparently be able to understand what is meant by that term. But think about it, what we need here and what we're trying to do with SNOMED is to help our computers and machines to help us reason over these clinical informations. So therefore, we also need a common language for computers, because with this approach here, we end up with something that is not intuitive and processable for computers. So we need a common language that can be understood by both humans and machines. And SNOMED CT can function as a hub here. Because we have the consistency within our identifiers, a SNOMED CT identifier never change. So this identifier here will always be linked to the same clinical idea. And as we've just discussed and you've heard, we have several descriptions that can be associated. So SNOMED CT still allows us to use the terms that we want in the different locations, but just linking them to the same clinical idea. So this is what we mean by using SNOMED CT as a common language that can support communication, because in this case, if we forwarded this code to another system and the system had the ability to look up SNOMED, they could see the defining characteristics, they could see the different synonyms, and then they would understand what is meant by that code. Of course, when you start to implement SNOMED CT, there will be places where you can't just go and change the terminology that you already have in your systems. So in those cases, you would need to then map from your local code systems to SNOMED CT. And that can still be a solution in many cases where you have some legacy codes that you want to retain, or you don't have the bandwidth to do a complete swap of your terminology. Then you would use a map, and you could still use that as a hub. You don't have to do that in every places. You can do it where that's sufficient. So in this case, SNOMED would still work as a common language. And it's not just about communication when we talk about using SNOMED as a common language. It's also used to integrate data. It may be you have various devices. It may be you have GP systems that you want to integrate with the hospital systems, or you have pharmacy systems, laboratory, and you, of course, also have a lot of analytics platforms, and it can be insurance and other systems that also use clinical data. So that integration goes beyond just electronic health records. It goes across all the clinical information systems that's used in the healthcare sector. I want to show you an example of using SNOMED for analytics and management, how that can be built up. You can consider different organizations at the point of care documenting clinical information. To have, like, if you want to do some analytics on these data sets, you could forward it to a SNOMED CT enabled repository. We could imagine that these hospitals up here are using SNOMED CT in their legacy systems or in their hospital systems, but this system down here doesn't use SNOMED CT. And so they have implemented a map from SNOMED CT to from their local system to SNOMED CT, so they are able to report to this repository too. What you gain by having a SNOMED CT-enabled representation of data from various places is that you have this collated view of all the patient data that you have captured. And then you can, so it's a very efficient way to get a large amount of data that you can then do analytics over. So that it may be from a national perspective, you want to do research, analytics, management. And then you can, instead of going out to each of the hospitals, you can start to query one single place where you can then create the groups of people you want to look at. It could be a certain condition. And then you can also use the SNOMED CT features to do more advanced analytics. In my next presentation, I'm going to show you all the various ways that you can get analytics information out of SNOMED CT, some of the various techniques, because you can use subsets, you can use relationships, there are different ways, and I'm going to give you more insights to what you can actually do to retrieve data. But this gives an overview of what we mean by using SNOMED CT as a common language. The next thing is to use SNOMED CT as an indexing system, and we have already touched on this approach. So indexing is simply what you would do to enable data retrieval, and it links to what I just showed you here. So although you don't use SNOMED CT in your legacy system, it may be you use local code systems. It may also be that you have data captured using classification codes. So using SNOMED CT as an indexing system is where you go in and index each of the existing records with a SNOMED CT concept. And that will enable you to do that analytics, research, and reporting from your local system without having to do a full implementation of SNOMED CT. So you can say using it as an indexing system will give you the minimal disruption to your processes, because it can be used as an extension to what you already have. Using SNOMED CT as a code system is probably the most simple approach, and that would be where you simply use it to store clinical information consistently. With our example here with the slipped disk, you may use local or standardized terms in the user interface. They don't necessarily need to be SNOMED descriptions. But when you capture and what you put into your database or your data storage would be SNOMED CT identifiers. So here you simply use the SNOMED CT codes for storage. So that is what we mean when you use it as a code system, because that would be how you use any other code systems that are out there, simply to ensure that every time you want to represent a clinical idea, you use this concept. And of course, if you use local terms, you would have to go through the process of identifying a way to connect SNOMED CT to your local terms. So that would be via a map. Using SNOMED CT as a dictionary is probably one of the most advanced implementation approaches, because that is where you start to utilize the design features of SNOMED CT to query, to analyze, and to report. And also to link health records to knowledge resources. This is also, this could be documentation support, it could be decision support. So when you link your clinical data to some knowledge resources that can be utilized to trigger alerts or to help the clinicians to make a proper decision. So with this approach, using SNOMED CT as a dictionary, we anticipate that you have used it as a code system, or you have indexed your records using SNOMED CT, so using it as a dictionary. So this requires you to have a SNOMED CT-enabled representation of your clinical data. And here we then start to use the hierarchies and the logical definitions of SNOMED CT concepts. Some examples could be that you want to get concepts from a specific sub-hierarchy, you want to get concepts with a specific set of defining properties. As Liara has already informed you about how we define concepts via relationships to other concepts, also showing that this is the grammatical view that we have defined to show how concepts are defined. So pharyngitis here is defined with an associated morphology of inflammation with a finding site of pharyngeal structure. It's a type of disorder of pharynx, inflammation of specific body organs. It's an inflammatory disorder of digestive tract and an inflammatory disorder of upper respiratory tract. So when you use SNOMED CT as a dictionary, you can use these defining characteristics of all the concepts that you have stored in your data record to retrieve data, and to link to an alert or a trigger. And I'm going to elaborate on this dictionary approach a lot more in the next presentation, where I'm going to show you how the principles of doing subsumption and doing selective retrieval of data. So I'm going into more depth on this approach later. But the essence is that if you get to the point where you can use SNOMED CT as a dictionary, you can get more help from using for search and data entry features. So making more efficient data entry if you utilize SNOMED CT's descriptions to enable search, and using the defining characteristics to report specific concepts, and as I said before, to trigger alerts. The next approach is using SNOMED CT as an interface terminology, and that's to capture and display clinical information. So this is where you use the descriptions provided with SNOMED CT as the interface terminology. So you don't have to create that map between your legacy terms and SNOMED CT, but you can use the descriptions that you have embedded into your edition of SNOMED CT. And this enables both local dialect and national terms to be represented, and you can also specify the preferred and acceptable synonyms in a specific scenario. These language reference sets that we have talked about, you don't have to only have one language reference set. No, you can design a language reference set to suit specific professions, specific clinical domains. So different stakeholders can actually have their own language reference set that would indicate these are the terms that we prefer. It could also be based on use cases. For this use case, these are the terms that we prefer. So using SNOMED CT as an interface terminology is also an approach that can be considered. This is just showing you the US, an excerpt from the US American English language reference set for that concept, intervertebral disc prolapse. So you can see the range of different descriptions that is available with the international release for this concept. And over here, you can see that this is the fully specified name. You can see that by the semantic tag. It's also indicated by the F here. And here you can see all the various synonyms. This one with the star is the preferred synonym in this language reference set. And then we have a lot of acceptable synonyms. So the design of SNOMED CT really supports you to have that terminology displayed on the user interface that you want. And a key thing with using SNOMED as an interface terminology is to hide the identifiers. It's important for us that clinicians think in the clinical language and look at clinical terms in the user interface. It's evidence that if clinicians start to thinking in codes, it will also reduce the quality of the data. So speaking the clinical language is a very important design feature of SNOMED CT. The last approach is using SNOMED CT as an extensible foundation. So although SNOMED CT is comprehensive and have very many concepts, descriptions, relationships, it may be that there are areas where a country or an organization have the requirement to capture data that is not represented by SNOMED CT concepts. So sometimes there may be a need to represent new types of clinical data. So when using SNOMED CT as an extensible foundation, it may be that you are adding new clinical content to SNOMED CT. There may be something very specific for your organization or for your country that is not found to be general applicable to all member countries in SNOMED or to 2 or more countries in SNOMED International. So in that case, you would, like I just said before, with the extension mechanism where you can add your descriptions, you may also add additional pre-coordinated concepts that can be available to you. So this would be SNOMED CT extensions with locally required content. There's also the possibility that you want to go and do post-coordination. So this is also a part of the extensible mechanism of SNOMED CT, that we have this wide range of clinical concepts divided into these 19 top-level hierarchies, but we also have a formal language that allows us to combine concepts to build new meanings. I'll just show you an example. So this is where you represent a meaning by the combination of the meanings of the concepts that you refer to. So in this case, we have a hip joint, the concept hip joint. We have what is called an attribute, so the relationship type, laterality, and we have the concept right. And if we combine them in this way, these red symbols here is part of the compositional grammar, which is a SNOMED CT computable language. So with this composition here, we are expressing the meaning of the right hip joint, because we have a hip joint with laterality of right. And these terms here can be omitted so that we can express it very briefly. And computers would then be able to interpret that it would be what the meaning entailed by this expression would be. The third approach to using SNOMED CT as an extensible foundation is that you create terminology derivatives that may be suitable in your context. An example of this would include maps to or from SNOMED CT and the code systems that you may already be using. It could also be that you create subsets or sets of concepts that are used to group things if you want to do statistics or if you want to do some other analytics, then you can use subsets. It may also be that you are as part of an implementation, you are creating value sets that you would use to bind the terminology to a user interface. So that would be a third part of using SNOMED CT as an extensible foundation. So I've taken you through this range of things that approaches you can use, implement SNOMED CT as a common language, an indexing system, a code system, an interface terminology, a dictionary, and an extensible foundation. And of course, you may be thinking, well, we want to do everything, and that's perfect. But a recommendation is that you think about your use cases and think about, okay, where should we start? Because SNOMED CT is not, as I said in the beginning, one size fits all. You can select which one of these approaches you want to take. It may be that you want to use it as a code system and as an interface terminology. Then you start out there. It may be that you want to use it as a common language to integrate data from specific systems. It may be that you are using it as an indexing system within a specific domain of your data, so that you can start to do some specific analytics that you want to do. So it's not, you don't have to use all of these puzzle pieces at first, but you need to analyze your use cases and identify what approach that would be suitable in your case. And even doing it in this way with the incremental approach, where you just take one step at a time, will actually help you achieve benefits from the start, instead of having to go through a very, very comprehensive implementation project before you start to realize some benefits. So even the simplest use of SNOMED CT using it as a common code system or a common language will start to give you benefits. And then you can always step up and start to implement services that will allow you to use it as a dictionary or other things that you would want to do. The next thing I'm going to speak to is some interoperability challenges. So I started out showing you how slipped disk or the intervertebral disk prolapse may be represented in different ways or using different terms or different codes. But in reality, there's more to this challenge when it comes to using SNOMED as a common language and ensuring interoperability between the systems. Because you can also imagine that you have systems that are representing the same meaning differently, not just in terms of the terms, but even in the way it's captured. So here you have an example of 3 hospitals, and each of them have a user interface where they could record the fact that a patient has a suspected lung cancer. So over here in Hospital A, they record the problem is cancer, it's situated in the lung, and the status is suspected. In Hospital B, they have a drop-down list here where they can select lung cancer, so a more detailed term here. But again, they also, like here, have a status field where they can indicate whether it's suspected, confirmed, or not found. But over here, they have a different value set because here they just have the ability to enter suspected lung cancer. And in SNOMED, we have concepts for all of these, but it's not the same concept. And then you can start to argue, well, how can we ensure interoperability between these hospitals when they use different concepts? And I want to show you how SNOMED CT can actually help you to overcome that interoperability challenge. So here is a diagrammatic view where Hospital A have these entries. It's the same information model that they use to communicate this data. They use this condition model, where there is a code, where there is a body side element and a status element. And Hospital A have an entry for each of these. Hospital B only has an entry for the code and for the body side. And Hospital C has only have a value in the code of this information model here. Consider Hospital A. The code is represented by this SNOMED CT concept, malignant neoplastic disease. The body side is the lung structure concept, and the status is suspected, which lies in the qualifier value hierarchy. Hospital B uses the same concept for the lung structure, for the body side, which is the lung structure. But they use a different code, suspected malignancy, as their condition code. But if we look at how suspected malignancy is defined, it's a type of suspected disease. And if you go down here, is defined with an associated finding of malignant neoplastic disease and a context of suspected. So although they don't have an entry for the status, if you consider that the information model with the code, the body side, the status can actually be derived for this concept from the definition of the code that they used for the condition. So the computer can automatically go in via these relationships and see, well, this concept here has a status or context of suspected. And if we then compare that to the first hospital, you can see that the code suspected malignancy that Hospital B uses also has a link to the finding malignant neoplastic disease. So we know that this is the Hospital B is actually referring to the same disorder as Hospital A. And the body side is the same, and the value for the status is the same. Hospital C records suspected lung cancer. So they don't have that field for the body side and the status. But again, if we inspect how suspected lung cancer is defined, we can see again that it also has a context of suspected. There's no body site. If you look at here, there's no body site, but there is an associated finding, malignant tumor of lung. And malignant tumor of lung, if we look at how that's defined, it has a finding site of the lung structure. So from this single concept, suspected lung cancer, we can infer both the status and the body site. So what we get from this analysis, and this analysis is of course something that computers can do automatically by traversing our relationships that are distributed for all concepts. So what the machine will tell you is that, okay, it looks like we are recording things very differently, but actually we can infer values for each of these entries. And we can even, because these two concepts come from the situation hierarchy, where this comes from the finding hierarchy, we can also derive the findings associated. So some transformation of our data is possible to have a more homogeneous representation of the data that will allow us to communicate and to query data. So by this approach, we ensure that even though you use different SNOMED CT concepts, that formal definition and the hierarchies will allow us to compare the concepts and to ensure that if we want to use it for counting occurrences, we can still do that, even though it's not the same concept that has been recorded.